we talked just a few minutes ago, guys. You have, just a reminder, you even mentioned you have a problematic due next Thursday. It's already loaded. It's in Google Classroom, ready to go. When is your next assessment?
Next Wednesday.
Next Thursday.
May the 9th.
That's my birthday.
Tuesday.
May the 2nd and 3rd.
All right, 2nd and 3rd, Leela Beth, very good. Very good. That's Tuesday, Wednesday.
Is it a quiz or a test?
I'm sorry.
Leela Beth, is it a quiz or a
It is
test?
quiz.
It's a quiz. When
Quest, actually.
do we have our bigger next due date after that, James?
On my birthday, May 9th.
On James's birthday, May 9th. And
Why is it up there?
Thank you.
What'd you get from?
what does it say?
No, I'm talking about James' Tuesday, May 9th. Happy birthday.
I don't have May's up there. It's April and June.
Oh.
What do you get today? What do you want for your birthday?
Shh, guys, we're on this.
Okay.
Seriously.
Well, thank you, everyone.
All right. So we're going to now, yesterday we talked about what to do if your denominators are the same and you're basically combining the numerators into, either adding or subtracting, but combining like terms, simplifying and going from there. So if the denominator is not the same, what do you do when you have just your basic fractions? Like right here we have 3 over 5 plus 5 over 7.
You're going to want to find a common denominator.
You're wanting a common denominator, which turns out to be what?
35.
35. So how do we get from 5 to 35?
Something that they can both.
And by 7. And then what do you multiply the 7 by? 5. So we'll multiply the numerators respectively. Then what do we do to that 35, the denominator?
You keep it the same.
You just travel it on along, keep it the same, and then we add or subtract the numerators depending on the operation provided. So what would the answer be to 3/5 plus 5/7? 46 over 35. Oh, really? It's just, this is 2 days with that. So we would have 46 35ths. Now, is that, can you leave it like that?
Yes.
No.
Yes, you can, but it is technically classified as improper. Is it in simplest form?
No.
Yeah.
Oh, yeah.
No factors are shared by 46 that are shared by 35. So, we're going to look then at this next set with some variables. All right, the biggest thing to do is to look at what they share and what they don't share as far as denominators go. So, we have and guys, what 5x squared y? What operation is happening between those three? That's all multiplication in that denominator. A number right beside a letter just means it's multiplying. So that means we have a 5, we have an x squared, and we have a y. Agreed?
Yes.
Agreed.
All right. Then we have the second fraction. And how do we break that up?
3.
We have a 3, an x cubed,
Y cubed.
and a y cubed. All right. Now let's look at just the numbers only, our coefficients. We have 3 and 5. Do they share anything?
No.
No. But what do they make up? 15. So that would be the coefficient of the new shared denominator. LCD,
Least common.
least common denominator, lowest common denominator. But
X to the fifth.
no. So between x squared,
X to the 6.
no.
X to the 3rd.
All right, look, guys, look. If we take our x squared and we write it like 2 x's, because that's what it means, and we take x cubed, which means we have how many? 3. So what do they share?
X squared.
And then what do they not share? X. So it's going to be x cubed. What they share and what they don't share combined.
Oh, so is it just like the biggest?
It is.
Oh, yeah, okay.
Wait, so you just turned into the biggest one?
Right.
Take a bigger X.
Right, but somehow that wasn't, y'all weren't quite, so I went back and explained a little further. So between y and y cubed, we're going with y cubed.
Hey,
Y cubed can make up y cubed by like times 1, and then y can become y cubed by multiplying by,
3.
that's 3y.
Wait,
How can y become y cubed?
Y times squared.
Y times y squared, good. So, that's, are you seeing how we got that denominator? I'm not asking for the solution, just finding the denominator, common denominator.
So multiply the coefficients and then go to the bigger variables.
No, not necessarily. You wouldn't just multiply the coefficients. If you have 2 and 4, what would that be? 4. If you had 6 and 8, what would the denominator, what?
24.
24. So it's what the lowest thing that they have in common that they can both create. Like if you had 6/8 plus 3/4, your common denominator, is going to be 8. All right, let's look at this next one. This gets fun and entertaining.
Wait, and for the numerator, you just 1 minus 8, and then...
No. Same process as working with regular, like if we were working with our 3/5 and 5/7, you'd multiply the 3 by 7 and the 5 by 5.
Oh, yeah.
Okay, we'll do the same, and we're going to get there. We'll do the same thing here. You'll figure out what you would do to 5x squared y to get 15x cubed y cubed. And that's what you would multiply the 1 by. All right, common denominator for b. We have
X cubed.
an x cubed. And we have this in parentheses, x plus 1 kind of stands off by itself, okay? You don't distribute the x to get x to the 4th plus x cubed. You leave it factored all the way. But the parenthesis thing, it travels together. It doesn't get separated. And then we have an x squared. And then we have an x plus 1. But how many times is it used?
4.
4 times. So, common, what do they have in common?
X cubed.
X squared.
They have in common x squared, but what is it going to be when it's going to be x cubed? What is the last part going to be?
X plus 1 cubed. No, x plus 1 to the 4th.
Yeah.
Leela Beth, rocking it, girl.
Good job.
Why?
Good job.
Because
Elizabeth.
it's the greatest power.
It's the larger power hanging out there
So we don't even have to we just pick the bigger number?
of what they share.
Oh, okay. We don't have to write.
Then, so this one would be x cubed. Well, you're going to have time where they have factors they don't share.
There's a 4.
I don't know. You figure out. I want you to factor C and come up with the common denominator. Factor the denominator.
C is our big.
Dr. Graham, come back.
Look at you.
Everyone's
Doctor, you left your shoes. You got kids.
There's a doctor on the whole other
And Instagram. Everyone likes it. Subscribe. Everyone on the recording.
got that.
No.
You left your shoe.
You okay, doctor?
So then what would the common denominator be?
4x squared minus 12x plus 9.
No.
Well,
You leave it
4x
factored.
squared.
You leave it factored.
What?
wait, you have to factor?
Wait, you
then find the least common denominator?
Oh,
Okay, we'll start again. Whoops, let me erase. Shh. Y'all can't be like seriously, just take into account, please. First denominator. What do they share? We've got to factor it out.
the first one, they share
A
4x.
4 and an x, which leaves us with
X minus,
X minus 3.
yeah, X minus 3.
4x squared and 12x share a 4x. So then you divide each out, and you're left with x minus 3. Then x squared minus 6x plus 9. When you factor that, x minus 3, x minus 3. All right, so when you list each factor, you have a 4, an x minus 3, an x minus 3, and an x minus 3. I mean, we have several of those. So when you list all of the factors, what do they have? What do they share?
X minus
They definitely share an x minus 3. And then what else do they not share?
4x.
A 4x. And so it's going to be 4x, x minus 3.
Is it not?
Even though they have 3 x minus 3s in common, you just list it once.
But why is the other one to the fourth, but this one's not squared, even though it has, the second one has 2? You know what I'm saying?
It's whatever.
Well, that one was just like
Yeah.
that one was starting out.
Because it's in the problem.
Oh, wait. So you would go the 4x, x minus 3, and then they don't have an x minus 3. So it's really another x minus 3. So it'd be 4x, x minus 3 times x minus 3.
Is it x
Now-
minus 3 squared?
Or x minus 3 squared. Now, what I would suggest is leaving this factored. I mean, you could take x minus 3, I know, and FOIL it and then multiply that by 4x. You want to leave your denominator as plain as you can. And here are
So you can
there are
cancel
reasons.
stuff out.
So you can cross things out to simplify. Also, where is this located in the fraction? In the denominator. This will help you see what the excluded values would be. In other words, we never want our denominator to be a 0. This will help you see that it can't be 0 and it can't be 3 without having to do a whole lot other work. All right? Then, do you have questions on what we've done?
So basically, the least common denominator is 4x, x minus 3 squared.
X minus 3 squared. Yep. So then, let's look at the next page. All right, so we're looking to find, these are more unlike denominators. And it says to find the least common denominator, which we've just worked through. Rewrite each fraction as an equivalent fraction. Leave the denominator factored. Tells you right there. Don't put the denominator back together. But you'll multiply the numerator as needed. So you combine your your numerator, but leave your denominator factored. And then add or subtract accordingly. And then it always says, be mindful, what can the denominator not be? Because sometimes, yes, it can't be 0, but then you have to look at what factors you have and be sure that your solution isn't part of that, what the variables cannot be in the denominator. So in other words, if we're factoring away and you end up with a solution of, let's say, let me move this down a little bit. Let's say you're working it and you get a solution where x equals 4 or negative 3, okay? but you look back at your denominator, and you have a denominator of x plus 3.
Yeah, and then if you.
What can the denominator not be?
-3.
-3. Therefore, your answer would only be 4, because the -3 would make the denominator 0. So just be careful there. All right.
Is that for excluded values on the one we just did?
There are excluded values anytime there's a fraction. All right. Let's look at the first one. 5m plus 2n. What's the common denominator?
Amen.
mn. So that means we're going to multiply. I'm going to write the first one out really simplified, and then spread it out a little bit. I won't probably spread each one out like this. What do I do to get mn? To go from 5, to go from m to mn, you multiply by what? N. So that means we're going to multiply 5 by n. And what does that give us?
5n over n.
5n. And then how do I get from n to mn?
Multiply by n.
Multiply by m, which gives us 2m. So that means we have 5n over mn plus 2m over mn. Now our denominators are the same. When we add them, are the terms alike?
No, we can't add like.
No. So really, our final answer is this. 5n plus 2m over, and I can just erase one of those, over mn.
And your excluded values would just be 0.
Very good, because it's a variable standing alone, so mn. Now,
So
Let-
would you say m cannot equal 0, n cannot equal 0?
in this case, because they're the same exclusion, you could just list it, mn cannot be 0. If they were different numbers, which you would do m cannot be and n cannot be. All right. Does that make sense, what we just did? Anybody not sure? I'll give you a second to look at it. We're good, good, good?
Good.
All right, I'm going to erase this before we move to B. All right, you start looking at B to see what in the world we have. Let's list out our factors for the denominator. We got to get them common.
3.
So we have, in our first fraction, bless you, we have a 3, and we have an a cubed,
And then we have a 9.
and then we have a 9,
And then we have an A.
an a, and a b to the 4th. So what will be the coefficient? 9. Not 18, not 27, just plain old 9. What about our a?
We're gonna have A to the 3rd.
A cubed. And what about our, I heard it, what?
B to the 4th.
B to the 4th. All right, before we go forward, are y'all good with how we got that?
Yeah, list them out.
Anybody not really sure what we just did?
Nah, we cool.
I love it. All right, 9 a cubed, b to the 4th. Okay, 9a cubed, b to the 4th. All right, I'm going to write this up here, and we're going to look at a cubed, b to the 4th. What did I do to get from 3 to 9?
Multiply by 3.
I'm going to have to multiply by 3. So that means, what's my numerator right now? It's a 2, so we're going to multiply and get what, Susanna? 6. All right. I have,
Oh, yeah.
okay, to get from 3 to 9, we multiply by 3. So 3 times 2 is 6. I have 9, I have an a cubed in the denominator. how do I get to a cubed? I multiply by b to the fourth. In other words, yes, to get from a cubed to a cubed, we're good.
Yeah, which,
But we don't have any b's in the denom,
so you just gotta put.
so we got to do the whole b to the fourth.
Now on the second one, it just says 13.
Well, look at you. No. Oh, the number.
You gotta add a squared.
Plus, so the number part, 9 to 9 is 13. But to get from a to a cubed, it's going to be, and then b fourth to b four.
Can you cross off?
Wait, what?
Can you cross off?
No, because you don't want to lose the denominator. You just know you don't have to now, if you're working it up there, I don't want you to lose this, but in your work, I would with my pencil, I'd go, well, I have an a cubed. I would with my work. I just didn't do it on here because I didn't want to mess you up. She asked, could we not cross that out? But yeah, on your work, I would certainly make it, I would let you see that we've gone from a cubed to a cubed. And maybe you make that a 3.
But don't change the final. Like, don't change the final.
Don't change the 9a cubed b to the fourth. But on your workspace, absolutely. That would be very helpful visually to get rid of that part.
I don't understand how you got 6b to the fourth and not 2b to the fourth.
Okay, we have,
Because you had to multiply by 3 as a 9.
Well, yeah, cause
the numerator is 2. So how do we get, all right, let me write it right here. If I have 9, well, if we are trying to get from, I'm kind of going backwards. If we have a denominator of 9, how do I get to, of 3, how do I get to 9?
Multiply by 3.
I'm going to multiply this 3 by 3. So whatever I do to the denom, I have to do to the numerator, right?
Yes.
So I'm going to say 3 times 2. Are you with me or over there? Okay. Well, I looked up and you were over there. So 3 times 2 is 6. Because you had to multiply, you had to do to the numerator what you did to the denominator. In the numerator, are there any common, what?
How do you know what to multiply to the numerator and then to the denominator? Because you didn't multiply everything.
Well, we took each letter apart and did it. Were you not
Of course, I was listening the whole time.
all the way with us? Look, okay, well, back up. Make sure. So, I'm not sure where I lost you then. Let me erase what we've got. I'm going to write the numerator back up there. And we are trying to get to 9a cubed b to the fourth. All right, that part makes sense.
That part makes sense.
Okay, so I've got to figure out what do we do to the denom to create this. And whatever we do to create that is what we'll multiply the numerator by.
Okay.
So if I have, let me change colors. If I have a 3 in the denominator, what do I multiply 3 by to create a 9?
3.
Times 3. What's my numerator right now?
2.
A 2. So I'm going to take that 3 and multiply it by the 2.
Okay.
There's our
That's
6.
6.
Okay, that part's good?
That part's good
All
for
right,
now.
now we're going to go to A. We have, in our A, we have an A cubed. I got to get to A cubed. How do I get from A cubed to A cubed?
No, you don't do anything.
Well,
It's already there.
multiply by
1.
1, technically. But you're right. You don't have to do anything because it's already there. So that means I would multiply 2 times 1. And, we would multiply the nothing that's sitting there with the 2. We wouldn't have to bring in any A's.
Okay.
Does that make sense?
Yes.
Then, I have in the numerator, or my new denominator, I have, change color, a b to the fourth.
Okay.
How do I create a b to the fourth? I don't have anything there. So I'm going to have to multiply the denominator by what?
1. Wait, so for b to the fourth.
I'm going to have to, if I don't have a b to the fourth,
Oh,
and I need a b to the fourth,
you multiply by b to the fourth.
by b to the fourth, so I'll
Okay.
multiply the numerator by b to the fourth.
Okay.
So there is our 6 b to the fourth.
And then the 13, how'd you go from, because you tried to get 9 or something? How'd you get to
All right, how do I get from 9 to 9?
1?
times 1. So what's my numerator?
Oh, 13 times 1.
13 times 1 is 13.
Okay.
I have an A. How do I get to A cubed?
A squared.
But I don't have any A's above a 13.
No.
So A squared.
Okay.
B to the 4th, how do I get to B to the 4th?
You times 1.
Yeah, or, yeah.
Okay.
And then so I don't have to put any B's.
Okay, that makes sense. Thank you.
Then, oh, absolutely. And then 6B to the 4th and 13A squared, do they share anything?
No, we can't do it.
No. So we're done.
Let's go.
Now, let me bring this up. Just making sure that you're good with this part. I am sure. Wait, hold on.
When
Do what?
would you do excluded values on this, since you're never really?
Oh, okay. On this, what would the excluded value be? 0. Just because it's just 0. Now, because all the variables are being multiplied by numbers.
But because you're not technically ever crossing off on the numerator. I mean the denominator.
We're getting there.
Okay.
We're going slow. Baby steps. It's. Yep, we're going to do that in just a second. All right, then here's what I want to. If this is one, not yet. Not yet. We'll get there. If this one doesn't work, it's a good explanation. Got one that I'm going to go with. All right. Let's look at the subtraction. Y'all figure out what the common denominator would be?
It would be -1 x plus 6.
Let us go.
Right?
All right. All right, this is my time to say what I had to say. All right. Have any of you ever, had a friend over? Or maybe more than one friend?
Never in my life.
All right, smarty pants. So, I am sure, okay, let's pretend we're at lunch. And y'all go and sit down at the lunch table with friends. And when you are, or maybe you've gone out to supper with a group and y'all are sitting at a table, it is not the right thing to do to totally exclude somebody. And to turn your back, never talk to them, and everybody kind of puts baby in the corner, if you will, and sits over here and ignores. That's hurtful and not nice and makes people feel.
One friend that you bully, you know.
Yeah, it's kind of like that. So we don't bully in math class, do we?
One friend you take advantage of.
All right. So that is what I want you, y'all listen please. That is how I want you to look at problems like this. If you have an x plus 3 or an x minus 2, the plus and the minus, it's like they're holding hands. They are connected, okay? So you can't do to one without doing to the other, or that's mean. All right? So in other words, if I have, right here in this first problem, I have x plus 3 over x minus 6. I can't, there you go. I can't cross out 3 and 6. You cannot simplify them. You want to go 1/2 so bad you can't stand it. But the x's, they're connected to x's. What's the coefficient for the x's?
1.
1. And if I have a 1 in front of each of those, no. Now, if, say, maybe it were 3x plus 3, 3x minus 6, you could remove factors then. But it's got to be all or nothing. It's like treating somebody mean at the table, okay? You can't ignore the coefficient if it's just 1. And I think it'll make sense as we work these. You can't start slicing things off and cutting them in half. All right, so let's see what we can come up with as a denominator. What is the denominator of the first fraction?
X minus 6.
X minus 6. And we've already established, James, we can't change that, can we? We can't simplify the x minus 3 and the x minus 6.
No.
So, first denominator is x minus 6. Second fraction, x plus 1, x plus 6. Can we simplify that?
No.
No. So what is the denominator for that one? X plus 6. Do they share anything?
That's it.
No, they don't.
It's a tail, it's like a tail.
They have tails.
Yeah.
You can't, you can't
Can't
pull
exclude
things
it.
apart. That would be mean, wouldn't it? Be a bully. Be a mean thing. So what is the denominator?
X minus 6. Parentheses
Can
X
I
plus
just change
6.
to negative?
I'm talking about denominators. No, It would go to the numerator. So our common denominator will be x minus 6, x plus 6. And you could write it x plus 6, x minus 6. It wouldn't, either way. All right, so do we agree on how the denominator? So that means we've got to look at the denominators to figure out what we did to them. So I'm going to write this one up here, x minus 6, x plus 6. What did I do to, or what will I do to x minus 6 to create that denominator?
I would get like factor.
So if I have x minus 6 and I want it to become x minus 6, x plus 6, what do I have to multiply x minus 6 to get here? What?
X plus 6.
X plus 6, thank you. So I'm going to say x plus 3 times x plus 6. Because I already have an x minus 6, so I don't have to do it again. So then that means I have to do what? FOIL.
Wait, what?
Yeah, I kinda lost.
Okay, if you have two binomials and I multiply them, what do you do to them? You FOIL.
Whoa.
Anytime.
Why'd you just take off the X minus 6?
Because it's the denominator that you already have. It's like over here when we didn't use the the a, we didn't use everything. So if I already have an a minus 6, I don't put it in twice. Okay, hold on. I need your undivided all the way with me attention. I need the conversation to stop. If I have x minus 6, and I want to get to x plus 6, x minus 6, I don't want x plus 6, x minus 6, x minus 6. I just want x plus 6, x minus 6. What's the difference between the left side of the equal mark and the right side?
Well, the first one has a numerator.
Oh my gosh, I'm looking at the denominator.
You can just cancel out X minus 6.
There's an X plus 6.
I have x minus 6 on this side.
There's a positive.
I have x plus 6, x minus 6 over here. Who can tell me what the difference in the two?
There's an
The
X
right
plus
side
6.
has an X plus 6.
I want the
Thank
binomial.
you. Right. I want the first side to become a binomial. What's missing from it?
The X plus 6.
X plus 6 is missing from x minus 6. So that means this is the new denominator. I'm trying to get there. Trying to get over here. What do I do to this to get here? I multiply it by x plus 6. That's what I have to multiply by. I now have in the original, yes, we have a numerator, and it is x plus 3. What did I do to the denominator? You multiplied by what?
X plus 6.
So what do I have to do to the numerator?
Multiply by X plus 6.
Then it would be.
It's a FOIL, so it's going to be X squared.
So do you not see, Bernie, that you have to FOIL that?
I do. I know you had to FOIL.
Well, earlier you were like, you what? Like you were like you had no idea. I was just making sure that you see why it's FOIL. All right, so what do you get when you FOIL?
X
X
squared
squared
plus
plus
9x
9x plus
plus
18.
8.
All right. Does anybody have a question about how we got the new numerator for the first problem? That's the first fraction.
Wait, we have a whole other.
Guess the first one.
You're just doing the same
Wait,
thing.
before, I just don't talk unless you have a question about the first fraction. Is there a question? All right. So right now, we have x plus 6, x minus 6. And then when we FOILed, we got x squared plus 9x plus 18. Please stop. Then the second fraction, what am I going to have to multiply it by to get to the new fraction? X minus 6.
And then it's
Now, let me say something. This is subtraction. That means when you start to work it, it's going to be plus, and we're going to change the signs of everything after, because this is like saying negative plus -1 times x minus 1 for the numerator. X plus 1. So that means you will have a numerator of -x and a -1. So it'll be negative x. Well, I tell you what we're going to do. That's right. We'll make it a little easier. We'll change it in a minute. We're going to leave it x plus 1 so that our lead can stay that. So we'll have minus, and then we'll have x plus 1. So when you FOIL, what do you get?
X
x squared minus 5x minus 6.
X squared. Hold on, we're going to go there. X squared minus 5x minus 6. Are you good with what we've done thus far?
Now do we have to change?
Then we need to change the signs inside of the whole thing. So let me change my color. We're going to become plus minus x squared plus 5x plus 6. Good? Do you see why we did and what we've done? Yes, ma'am. Now you're going to combine like terms. So let's look. We have x squared. What's our other x squared?
Negative. It's 0.
Oh, we got us a 0. 0.
Then it's going to be
Then we have, what about our x's? How'd you get that?
you just add.
Good stuff, Jordan.
Good stuff, kid.
Okay, he's not going to say what. What did he add? 9x plus 5x. So that's 14x.
Plus.
Then what?
24.
Yeah, plus
24.
All right. And then that leaves us over x plus 6, x minus 6. Now, let me ask you this. 14x plus 24, do they share anything?
They share,
yes.
they share a number. They share a 6. Boom.
No.
Just a 2.
Boom.
They share a 2. That would leave us. Guys, could you stop and stay with me? We're going to run out of time and you're going to have to figure it out. Please stay with me. So they share, so it would be 7x plus 12. Now, you take a quick glance at this. Does that give us an x plus 6 or an x minus 6?
No.
No, so we leave it 14x plus 24 over x plus 6x minus 6. You want to be sure that they can't cancel out anything.
Negative 6 and 6. Excluded.
Perfect. Excluded values, negative 6 and 6. All right.
Why do you leave it? Because
You're to multiply the numerator, you do that. But then I always do a quick glance to see if I could factor it. Would I be able to remove any part of the denominator, like by simplifying? And in this case, you can't. Like I didn't get an x plus 6 or an x minus 6. So no need. All right. I want you to work A and C. Or I tell you what, y'all work A, we'll work C together. You work A. You work A. I'm going to erase. Is there anybody that's writing anything from this? All right, you work A. Oopsie daisy. Stay with me. There we go. Remember to factor. Figure out what the common denominator would be.
Oh, I got it.
What's the denominator, William?
6.
3x plus 6.
3x plus 12.
Yeah, wait, I got 3x plus 6.
3x plus 6.
It's 3x plus 6 because the 12 doesn't. You don't have to multiply, I don't think.
Because you just multiply plus 6.
No.
3x plus 2.
You're wrong.
What, Stuart?
3x plus 2.
3, and then in parentheses, x plus 2.
Yep.
Excellent.
Oh. Oh, yeah, because you factor it again?
Leave it factored. Shh.
So it would be 2 parentheses x plus 3. And then
Okay, so you have x plus 2, and then in the second one, they share a 3, which leaves us with x plus 2. So, whoops, that 2 went away. Hold on.
How's it not x plus 6?
I'm about to show you. So, we have x plus 2, we have a 3, and we have x plus 2. Those are our 3 factors that make up all the denominator options. What would the coefficient be? In other words, just the number part.
3.
3, because there's only one number that's involved. And then what do they share?
X plus 2.
X plus 2. So we're through. That gets rid of everything. X plus 2. You were told always to leave the denominator factored right there. Don't put it together. So it's going to stay 3x plus 2. Several of you were saying 3x plus 2. But it's 3x plus 6 is what it would be if it were put together. But you leave it 3x plus 2.
so would you do anything in the second one?
Dr. Graham,
Yes, ma'am.
I need Will Drennan for dismissal, please.
He's already packed up and ready to go.
Okay, thank you.
Thank you.
Adios.
So would you do anything for the second one?
Is that the denominator?
Yeah.
There you go.
Oh, okay.
You have 10 through 22.
Good, Will, good.
6 problems.
How do they even
You
have
have 10 through 22 even.
Oh, I have that sheet already.
Okay.
I'm figuring it out.
Bye.
I'll get it.
Jenna, where are you
I
going?
got this.
Where are you going?
I don't want you to hurt yourself further.
All right, bye guys.
Bye.
Bye.
Have a good day.
All right, so what did you get for your final answer?
3x plus 16 over 3 parentheses.
Perfect. Yep.
That's what I got. But I got 16 plus 3.
I got 6x plus 17, so I think I'm doing something wrong.
I mean, you can have 3x plus 16, 16 plus 3x. Same thing. So, we agreed that the common denominator is 3x plus 2. So let me get rid of my stuff. 3x plus 2. What did I do to the first denominator to get to 3x plus 2? What's missing? Do what? Multiply by 3. So what is 3 times 5?
15.
15. Then, what did I multiply Oh, and we factored here, and we got it to be 3x plus 2. How do I get from 3x plus 2 to 3x plus 2?
Wait, what?
2. Multiply by 1.
By 1, thank you. The denominator is 3x plus 2. So then we have plus 3x plus 1. And then when you start combining that,
Wait, how did we get that? The 3x plus 1 part.
well, that's the numerator right there.
Oh, that's the second one.
We finished the first one with 15. And then we
Oh.
moved over here, and that's when I was saying, how do I get from 3x plus 2 to 3x plus 2? There's no difference. So the numerator doesn't change. So that gives us 3x plus 16 all over 3x plus 2. All right, good?
Yes.
What do you not understand?
No, I'm like, I'm good now. Like I just like start understanding. Like, you know.
Like, just like, one was like,
Oh, like, no, like.
I don't know. All right,
Bro just said yes and
so
instead of BT.
what is the common denominator? Figure out what it would be for C.
Oh,
Shh. I have people that aren't even looking at the paper, so I'm not sure if they're with me or not.
X squared. We have an X
Squared
squared.
plus 1.
X squared.
What?
X
It
squared
has
plus
to
1.
be no,
X
x
squared.
plus 1 and x minus 1 together. So
Right.
X squared minus
X squared
X
minus
squared
1.
parentheses.
Okay, let's do it. Let's put it. See what we can do when we take it apart. What is the first numerator? Means first denominator.
X plus 1.
What is the second denominator?
X squared minus 1.
Factor it.
What? X minus
Factor
1,
by one X.
minus
It's difference of perfect square. X plus 1, x minus 1. What's the third?
X minus 1.
So, what do they share?
x.
No, they don't. There is no x sitting there.
Nothing. 1.
None of those four are the same.
Well, yeah, I mean, there's like.
Well, the first two
They share an X.
X plus 1 squared, x minus 1 squared.
The last two
X squared
share
plus
a
1,
negative
X squared minus 1.
My goodness.
X plus 1, X minus 1?
Yeah. So, looking up here, do we have anything that repeats? What?
X plus 1, X minus
All right, we have to do this in baby steps. Only one thing at a time. So what do they share one time?
X plus.
They don't share an X. These are like what we've talked about. They have the plus thing. You can't break them apart.
Plus 1.
X plus 1 is shared. And the reason we see that it is shared is we have 2 right here. So we can cross that out. Is there anything else that is shared?
X minus 1.
X minus 1. The only time we could have like an X is if we have like 3X and we break that down into a 3 as well as an X. The X minus 1 is not an X sitting off by itself. It's coupled with either the plus or the minus 1 with these problems. And then this is X minus 1. That's the common denominator. So knowing that, what happens with the first numerator?
Multiply
By?
x minus 1.
Correct. It already has an x plus 1. And what do I do to x plus 1 to create x plus 1, x minus 1? Multiply it by x minus 1. So, we are going to write x plus 1, x minus 1 in the denom. Which means, what do we have to do to the numerator?
Multiply by X minus 1.
Yep, so we're going to FOIL x squared.
Squared minus 3.
So when we do our outer, So this is x plus 3,
X minus 1.
x minus 1,
X squared minus,
Minus 2x.
plus 2.
plus 2x minus 3.
Oh, yeah.
Are y'all good with how we got there? Now, x squared minus 1. What do I do to it to get x plus 1, x minus 1? Okay, who can tell me what x squared minus 1 is when you factor it?
X minus 1, x plus 1.
So what do I do to it? Nothing, because that's what it is. Just,
Yeah, it's like the last one.
so because this is really x plus 1, x minus 1.
So you just leave it X.
So you're going to, the addition part, so we're just going to say plus x minus 3.
Okay.
All right?
Okay.
Then, what do I do to x minus 1?
X plus 1.
Yes, x plus 1. Now, before you foil,
It's negative.
notice that we're going to put a minus and put it in parentheses. Yeah, and then change it. So minus, parenthesis, and then when we foil, what do we get?
X squared.
X squared.
Plus, what's 4 and 1?
5.
5x plus 4. All right, before we go any further, do we have any questions?
No.
This is not as hard as it look. I mean, take it like little bitty baby chunks at a time, and it's not as hard. What would be our next step?
Foil X squared plus 4.
No, you have to change it. It would be plus negative x squared minus 5x minus 4.
Ha! William, you're fabulous. So, I'm going to change color, and we're going to make this plus negative x squared minus 5x minus 4.
Wait, why do you have to change the signs again?
Because we had a subtraction. And it's easier to foil if we have the lead positive.
Yes.
So we put a negative and then change it.
Yes.
So, again, let's combine now our numerators. What about our x squareds?
They're 0.
They become 0. Cancel out, cancel out. There's 0. What would be next?
Negative 3x.
Where do you...
Negative 2x.
Yes, negative 2x because there's another x.
Here is an x squared.
Wait, what?
I mean a 2x. And here is an x.
Yeah, we
Then there's another 5.
And then there's a 5x. So what is that?
Negative 2x.
Negative.
Negative 2x. And then we've got some numbers in here. Boom.
Minus 3 minus
Negative
3.
10.
Negative 6.
Negative 10. Negative 3, negative 3.
Yeah.
And then the negative, yeah. Negative 10. Let me move that up just a little bit. All over
x plus 1 x.
x plus 1, x minus 1. All right, at a glance,
We could do negative x minus 5.
so is that going to help us out? Are we going to be able to cancel that out with our denominator?
No.
So we can leave it. Negative 2x minus 10. Now, if you changed it, you could do, like you said, negative 2, and then that would leave us x plus 5. But it's not going to change the denominator.
And then it's negative 1 and positive 1.
Oh, well, look at you. Negative 1 and positive 1. Are you good? All right. Look at this one. Add and subtracting rational numbers. You had it handed to you yesterday. No, you didn't. No, you didn't. No, you didn't. Sorry. I was thinking we did when I handed it to Will Brennan.
But Will was ahead of the schedule pretty
Yeah,
much.
Will's very ahead.
We did the first
7 or 8.
8 in class yesterday because they all had like denominators.
Yes.
Is this home?
This is going to be homework. 3, 4. Look at number 10. Go ahead, please, and figure out what the denominator would be for number 10.
Right. Check. Number 10.
We got an extra.
Thank you.
Dr. Brown. You're welcome.
7v squared.
21v squared minus 6.
What are you?
Is it 21v squared?
It's 21v squared minus 6, right?
Yeah, that's right.
Oh, no.
Dang it.
Wait a minute.
What if it was just like 21v minus?
It's,
Let's look at what the denominator. Y'all are, okay, let's look at the first one. 8 over 7v minus 6. Can we factor that any further? No. So we have a 7v minus 6. 4 over 3v squared. Can we do anything to it?
no.
No. So we have a 3 and we have a v squared.
Why'd you put the 7v minus 6 in parentheses?
Because it's an addition subtraction. It's a clumpy that hangs together. This is like you at a party. You can't ignore your friend. So, what do they share of these? Do they share anything?
They share a...
No, they don't.
Yeah, no.
They don't. Because you can't, if it's on the outside of the parenthesis, you can't share outside to inside. So then it is this. It's your coefficient is 3. And then you have a v squared.
Teachers, please excuse this
And you
interruption.
have a 7
Seventh graders
V
who
minus
attend Fixed
6.
Carrier Study Hall in room 209 should report to Coach Triplett's room 204 for study hall today and
That's
tomorrow.
your common
Thank you.
denominator. You don't put it together. And some of y'all were getting the 21, but if you had put it together, it would be 21v cubed minus 18v squared. But you don't put it together. You leave it factored. And EJ, why do we leave it factored?
So you can cancel out stuff.
Cancel out stuff and figure out what the excluded values are.
Yes.
So, what did I do to get from 7v minus 6 to the new denominator? Yes, you multiply it by 3v squared. Whoops. So let me just draw my line. What does that give us?
24v squared.
24v squared. What do I do to 3v squared to get to 7v minus 6?
Multiply by 7v minus.
So that's 28v and then minus 24. And you could remove a 2 from the numerator, but that's not going to get us to the 3v squared.
V can't equal.
You can't move a v out because the 24, the last one, doesn't have a v. And that's not going to factor
We can take out a 4 from the.
to set. Well, if you could take out a 4, but that's not going to get you to the 3. There's nothing you can do to the numerator to allow you to cancel out the denominator.
Maybe we can though, because it's 28v minus 24. If we took out a 4, that becomes 7v minus 6. Doesn't it?
Plus 24v squared.
Oh.
You would see, all right, let's say you removed a 4, you would have 4. You would still have 6v squared plus 7v.
Oh, and that's a tag.
I know, you got that thing down there. You got that 6v squared. And you can't start slicing. That's like leaving your friend over there and you're ignoring them when you're playing video games and you're ignoring them in the other room. That's not right. They're held together. They travel in tandem, holding hands.
So would
Okay?
the excluded value just be 0?
No, oh, I'm glad you asked. No. That would be excluded value for the 3v squared. What would the excluded value be for 7v minus 6?
6 over 7.
Positive 6 over 7. Make it equal 0. Move the negative 6 over as a positive 6 and divide by 7.
So we say for v squared is equal to like 0? And then
Because, you would have 3v squared equals 0. V squared equals 0. Because when you move a 3 over, and so that would just be 0.
He wants to do the excluded values for homework?
You know, Bernie, that would probably lend. Let's do excluded values for multiples of 3. Excluded values for multiple of 3, and you're doing the even problems. So
So you're even front and back, or just front?
only, no, from 10, we just did 10, so technically the back, since we did 10 together.
12,
So which ones will we do excluded values for?
12,
6, 12, and
15,
18.
18,
We're only doing the back,
12 and 18.
12 and 18.
12.
Oh, we're only doing the back?
It's evens
Okay,
10 through 20.
yesterday we did 1 through 8 together.
So just 12 and 18.
So we're doing, and then we just did 10. And so y'all will do 12 through 22 even. And then the excludeds will be for 12 and 18.
Hey, Dr. Ray,
Sir?
will you post this on our Google Classroom for us?